we are going to talk about the difference between standard deviation and variance. You can just Google the meaning for each and see how the formulas and the meanings for standard deviation and variance are calculated or differ. Essentially, standard deviation and variance are measures of inequality and disparities. They assess how and why something or someone is different. And they assess the extent of differences in a given variable. They also assess the degree of inequality, meaning how far a case or an observation is from the mean, or how far the value for that particular case or observation is from the mean. If we get a large standard deviation, it means there are greater inequality or disparity in that variable. If we get a small standard deviation, it means the difference is small, minimal or negligent for that variable. If the standard deviation is 0, it means that all individuals have the same value for that variable. For instance, the entire class can weigh 100 pounds. If that's the case, the standard deviation for weight would be 0. And when standard deviation is 0, we cannot assess the impact of weight on height in any regression analysis because there's no frame of reference and there's no data for other weights. Everybody is 100 pounds. So as you can see, standard deviation or variance, they portray the best and the worst picture of a given society. Or, to be more specific, standard deviation and variance, they portray the best and the worst of a given variables. And this is how the formula for variance looks like. And it looks very different from the formula for standard deviation. As you can see, standard deviation is essentially the square root of variance. Or when we square the standard deviation, we get a variance. And I'm going to show you more about that in the subsequent slide. So, here again, standard deviation is the square root of variance. And when you square the standard deviation, you get the variance. And here are the difference in the formula. So, as you can see, for each value in the data set for a given variable, if you square the number 1, you get a 1. If you square the number 2, you get a 4. If you square the number 3, you get a 9. And if you square the number 4, you get 16. So, even though, as you can see from these two formulas, standard deviation and variance are essentially the same thing, but they are used for different purposes. We use standard deviation when we want to keep values close to the mean. As you can see from the numerator, it indicates how far the value for a particular observation, for instance x, is from the center or the mean. X bar is the mean. And to assess variability, we square the difference between x and x bar. And when we want to make more intuitive sense, for instance, when we want to measure the sums of squares, it's more appropriate to use the variance. Because I'm sure you have seen online or in any statistics textbooks, when you take the sum of squares deviation, it gives you a 0. So everything evens out. So when you take a regression analysis, when you get beyond learning the measures of central tendency like mean, mode, and median, and the measures of inequality like variance and standard deviation, and you move on to different variants of regression analysis, and you want to measure the sums of squares for a variable, it makes more sense to use the variance. And when we use the variance, the negative and positive dispersion have a role in the measurement scheme. So, let me repeat. If we just want to see how far a data point is from the center or the mean, it's better to use the standard deviation. And if we want to do multivariate analysis, we want to measure the sums of squares, it's better to use the variance, even though they both mean the same thing. As you can see from the formula, you square the standard deviation, you get the variance. You take the square root of the variance, you get the standard deviation.